how are you? This is Math Lover and more. Thank you for watching my video. I hope that you are all well, healthy and happy, and that as you watch my video, you will learn more about math, and that you will love math more and also love life more. To start with, let me give you the objective for today. Solve real-life problems involving Z-scores. What are Z-scores? Z-score is also called a standard score. It's a measure of how many standard deviations below or above the population mean a raw score is. Standard deviation. It is a statistic measure that tells us how far a raw score is from the mean. Population mean. It is an average of a group characteristic. Characteristic means it could be people, places, or any other things that is being studied or analyzed. Finding the Z-score is a way to compare results to a normal population. When we say normal population, that means if we have the data and we graph them in a x and y axis, it will show a figure like this. Okay, so it's a bell curve, and in that figure, like for example, we are plotting these points that come from the data that we have, and it formed like that, and so that means that the population is normally distributed. There are data that are not normally distributed, but according to mathematicians, if you study more and more data, it will become more and more normally distributed as more data are being studied. Okay, so in the normally distributed population, we have here in the middle the mean, median, and mode. And we have here 0. Okay. Okay. And in here, okay, from the middle or from the mean to the right, we have this positive standard deviation. This is positive 1, positive 2, and positive 3, and so on. And from the mean to the left, we have negative standard deviation, negative 1, negative 2, negative 3, and so on. So it tells us how far is the score from the mean. So when you have maybe a score in the positive 3 standard deviation, that means the score is above the mean. While if you have maybe negative 2 or negative 1, that means that the score is negative 1 or 1 below the mean, or 2 below the mean. Okay, below the average. Okay, how are these Z-scores used in reality? Z-scores actually in probability and statistics, the analyzation of data is really important for us to make good decisions, right decisions, decisions that are beneficial for yourself and for other people. So, if we are already a master of these things, it will help us to make wise decisions. And wise decisions are really important in life. According to James 1:5, if any of you lack wisdom, you should ask God, who gives generously to all without finding fault, and it will be given to you. So, for us to make wise decisions, we need to ask it from God. God is the source of wisdom. God will guide us, will help us to do what is right and what is beneficial not only to ourselves but also to others. In Jeremiah 33:3, call to me and I will answer you and tell you great and unsearchable things you do not know. That is very, very wonderful thing to know. If we call on to God, we ask God for wisdom, God will let us see great things. We'll be able to see or discover unsearchable things. You see, mathematicians before, statisticians before, no matter how great they are, how intelligent they are, there are still many things that they didn't discover. There are still many things. And we ask God that as we continue to study, we will become more and more open for things so that maybe we may not be able to use it, the mathematical knowledge that we have. In the near future, we will be able to use them. And so let us welcome the opportunity to learn more and more and learn to love more, love math more. In life, we should always strive to make right decisions, learn from the past, live at present, and be the best in the future. So, let us not linger on the bad things that happened in the past. Let us learn. Let us let us just remember the lessons that we learn, and we live our life at present. We we grab every opportunity that we have at present and do what we can for the good of ourselves and the good of others also. And then make ourselves open for development so that we can be a better person and we can do great things in the future. So everything that we can learn, we do it. We don't say no, so that we will become the best person that God wants us to be. So let us see how Z-scores are used to make wise decisions in real life. Let us start with problem number 1. Professor Wallace is marking a test. The student's results out of 60 points are the following: 20, 15, 26, 32, 18, 28, 35, 14, 26, 22, and 17. Most students didn't even get 30 out of 60, and most will fail. The test must have been really hard, so the professor decides to standardize all the scores and only fail students one standard deviation below the mean. Was it a better decision? Why? So it is stated there that the professor standardized the scores. So the professor has this in his heart that he will not fail majority, because you see, most of the students got below half of the score, and we could say they failed. But then the professor find a way to help them. And he used standardization of scores, and that is the Z-score. And I want you to remember that when you use the Z-score, you need to convert the given data into a Z-score. And when you convert, you need to remember the formula. So this is the formula. Okay, the Z-score is equal to, okay, the X or the raw score minus the mean. That's the symbol for the mean over the standard deviation. That is the standard deviation. Okay. So, for us to be able to convert the scores of students, we need the mean and the standard deviation. The standard deviation of the scores. And so, we see here that there is no mean. But I hope that you already know how to find the mean. And there is no standard deviation of the data also. The standard deviation that is being mentioned here is that the teacher will only fail students that get one standard deviation below the mean. So earlier, I discussed that when this is the mean and you have a curve, and this is the mean in the middle. When you get a negative numbers below the mean, that will be below average. That means your score is below average. Okay. So let us see how to do this. Okay, so our first goal is to find the mean and the standard deviation. Okay, so I use Excel to compute for the mean and the standard deviation. So I hope that you already know how to use the Excel. You just have to encode the data. So I have here the data, the 20, 15, these are the scores. The 1, 2 until 11 are our n, the number of data that we have. We have the sum, the count, the average mean, the variance, and the standard deviation. We must remember that the standard deviation is a square root of the variance. So we will be able to find the standard deviation once we found the variance. And so here's the data in the Excel. We have deviation about the mean. So that is x minus the mean. So when you already put the correct formula for each cell, then it will just compute for you the mean and the standard deviation. So we have here the x minus mean raised to the power of 2. You don't encode there. You only encode in here in the x, the observation, the scores. And when the formula are correct, then it will just compute. As you can see here, the 48.4, that is the variance. So it was computed based on the formula that we put in the Excel in each cell of that kanang Excel document. And we get the square root of 48.4, and we have our standard deviation that is 6.95, and so on. So as for me, we will just use until the hundredths place. So 6.95. So we will get those information for us to solve for us to convert the given raw scores of students into standard score. Okay, so let us start. So we have here 20. So our Z-score, will be, it says there, the raw score. So we have first Mm. Okay, we have 20, and so 20. So we have 20, the raw score minus the mean. The mean is, as you can see, the mean is 23 in the Excel. It was shown there. So minus 23 all over our standard deviation. We got it also from the Excel, which is 6.95. So when you solve it, okay, so using your calculator, when you solve it, you will know that the answer is it negative or positive? Okay, so the answer is negative, negative 0.43. Okay, but that is not one standard deviation below the mean, because one standard deviation below the mean is negative 1, and then the negative 2, and so on. So that means that that standard deviation is passing. Okay, next let's have the second one. Okay, we have here 15. So we do the same. We use the same formula. So that will be ZScore is equal to 15 minus the mean, that is 23, okay, divided by the standard deviation, that is 6.95. And so when you solve it, you will know that the answer is negative 1.15. So as you can see, negative 1.15 is one standard deviation below the mean. And so this score is failed. So that standard deviation is corresponds to the student who got 15 points. So he or she failed good. Okay. Next, we have to convert also 26. And so we have here Z-score is equal to 26 minus 23 over the standard deviation, that is 6.95. And so your answer will be 0.43. So you see that's 26 minus 23 is 3 divided by 6.95. The answer is positive, and that is positive 0.43. So that is that below or above the mean? Positive numbers or positive standard deviation are above the mean rather. Sorry, it's above the mean. So meaning that is passing. Okay, because according to the professor, he will only fail those who got one standard deviation below the mean. When we say below the mean, that should be negative standard deviations. Okay, so you will have to compute all the other numbers, the same process. And so I already computed it for you. So we will see that the standard deviation, that the raw scores, when you use the same formula, that is Z-score. Okay, we have here Z-score is equal to the x minus the mean over the standard deviation. Then you will be able to know that after computing, these are the values, these are the Z-scores that correspond to every X score. So meaning the 20 points becomes the 0.43 and it passed. Okay, according to the professor, the grade that fails are those that is one standard deviation below the mean. So we have here negative 1.15. That is more than one standard deviation below the mean. So that is why that one, the person who got 15, failed. Okay, and so the one that got 26, the conversion, it converted into standard score that is 0.43 and it passed. 32 converted to 1.29 positive and so it passed. 18 converted to Z-scores, it becomes negative 0.71 and it still passed because it does not reach 1, negative 1. It's only negative 0.71. 28 is equal to a Z-score that is 0.71 and so that also passed. And then next we have 0.71 for 28 that passed. 35 converted to Z-scores, we have 1.72 that is also a passing score. But we have 14 when it is converted to Z-score, our Z-score that comes from 14. So Z-score is equal to 14 minus our mean that is 23. That gives us negative, divided by our standard deviation that is 6.95, and that is, when you solve it, that will give you a negative 1.29, and that is one standard below. The negative numbers means below, but this time it reaches 1. It is even bigger than 1. Below 1 standard deviation. That's 1.29. The negative symbol or the sign negative just tell you that it is below the mean. So the score is below the average. Okay, so we have 26, 0.43, 22, negative 0.14, and 17, negative 0.86. So as you can see, look at the scores. When you look at it before, you would say that almost all of them fail. But now that the teacher has found a way to help the learners, and so he standardized the scores, and as you can see, there are only 2 learners who failed. That is making wise decision to help others. So you must know that teachers are actually willing to help the learners. Okay. So the question is, was it a better decision? Yes, it was. Because when the teacher did not do it, then the learners will have failed grades or failed scores. And that is not good for the learners. Maybe the subject or the topic was just very hard. And so the learners are being assessed based on their scores that are relative to the scores also of the group. That is standardization of score. So your performance is being taken into consideration the performance of other learners in your class. And so you still pass. Okay? Even if the scores did not even reach half of the total score. Okay? Okay, let's have the second number. Okay. Oh, that was, by the way, uh, why was it better decision? Because the learners were being given help, and the computation of the teacher to give a passing score for the learners is also in line with mathematical principles. So he is not violating anything. He is not also guessing who will fail and who will, he will just, it's not that he will just choose whom he will fail, but he has shown fairness to everyone. Okay? By using standard scores. Okay, let us have the second. Suppose you are enrolled in 3 classes: statistics, biology, and philosophy, and you just took the first exam in each subject. You received a score of 82 on your statistics, and you have your on your statistics exam where the mean score was 74 and the standard deviation was 12. You received a score of 72 on your biology exam where the mean grade was 65 and the standard deviation was 10. Finally, you received a score of 91 on your philosophy exam where the mean grade was 88 and the standard deviation was 6. If you are asked in which subject relative did you perform the best relative to the rest of the class, and you say it was philosophy, was it correct? Why? Maybe you are thinking that you get 91 and the other is 72 and 74, so you are thinking that, oh, I'm doing great in my philosophy, I got 91. But to really measure your performance, it is good that you will use Z-scores. You could not you could not you could not compare these scores because um, they have different standard deviation and they have different mean. And so, for you to be able to compare them correctly, it's like you could not compare apple from a mango. Okay, they are different. And so, you have to make them the same. And so, you use standard score. So, you will change every score into a standard score so that you will see in which subject you perform the best. And so we don't need to compute for the mean, for the standard deviation, because they are all given here. But for example, you are analyzing your score, like in all your subjects, you want to analyze which subject you perform the best, then your scores, you get the scores of your other classmates, you add and divide how many are you in the class, you get the mean. And then you solve the standard deviation using Excel, and that's the time you will solve for the Z-score. Okay, so let us now solve for the Z-score. Okay, so the formula is always you have to subtract the mean from the given score. So our z-score for the first for our that is what's the first statistics. So our z-score is equal to, for statistics, you got 82 minus the mean score. According to the given, the mean score is 74, and according to the given also, the standard deviation is 12. So when you solve it using your calculator, you will get, the answer is 0.67. So that's positive positive answer, meaning your score is above the mean. Positive Z-score, meaning your score is above the mean. So that is good. Okay, let's proceed to the next. That was for statistics. Okay, let's have, we have here the, what's next? Biology. For biology, you have here, you receive a score of 72 on your biology with a mean of 65 and standard deviation of 10. So let's get the Z-score of your biology, and that is equal to, the mean is 65. Okay, 65 and the standard deviation, for a while. Okay, so your score, you will have to subtract your score. The score is 72, so that is 72. Okay, we have here 72 minus the mean, that is 65, divided by the standard deviation, that is 10. And when you use your calculator, you will know that the Z-score here is 0.7. This is equal to 0.7. Okay, so that is even bigger. Your score in biology is bigger than your score in statistics. Your score in statistics, the Z-score is 0.67, and 0.7 is bigger than that. So let us now see, you said that you perform best in the philosophy because your score is 91. But let us see if you are correct. So we have here Z is equal to, we have our score in philosophy, that is 91. That is our X. Minus, we have the mean, that is 88. The mean is 88. That is also a big average. And the standard deviation is 6. So the standard deviation is not that big. So we have 6. So when you solve it using your calculator, you will see that the answer is 0.5. Can you imagine that? The one that you said is the best because you got the highest score, 91. But in reality, your Z-score, your standard score is 0.5. That is the smallest standard, the smallest Z-score, meaning your performance in your philosophy is the least among the 3 subjects. So it is the opposite of what you are thinking. The real performance is based on your score relative to the scores of your classmates. So you are measured, your performance is measured based also on the scores and performance of your classmates. So that is what we call standard score. So the question here is, was it correct? You are proud to say, oh, my best subject, my best performance is philosophy because I got 91. No, mathematically, that is not correct. You have to make them to convert the scores into standard scores so that you will be able to compare them in a way that they are already the same measurement. So Z-score. So that's it for this. Whenever you want to compare your performance of the other subject, you use the Z-score. Okay? So I hope that you learned something today, and I hope that as you learn these things, you will also learn to love math and learn also to share to others. Thank you for watching my video. I hope that as you go home, you will see that these scores are really useful in real life in making decisions. I wonder. Okay, that's it. And so, thank you so much for watching the video. Thank you, and come back for more videos, for more learnings, for more fun. So, that is all for today. Goodbye.